Let's write a query. How hard could it possibly be? Welcome to this video on querying in SQL Server. My name is Kevin Fiesel. I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In this video, we are going to take a gentle walk through some T-SQL syntax and build up a query or three. If you're an old hand at writing T-SQL, you probably know all of this already and can take this time to wash the dishes or mow your lawn or call your mother or something. Seriously, call your mother. All right, queries. Let's talk about queries and operators. There are 8 important operators we're going to care about in today's video. Select, from, where, group by, having, order by, top, and distinct. Trust me, there are plenty more, but I gotta save something for the next video after all. The database we're going to use is Daniel Hoopmacher's Chicago parking ticket dataset. We installed it in a prior video, though if it's been too long since you saw that video, I'll include a link to it in the show notes. One quick warning, that database does require about 25 gigs of disk space available, as the city of Chicago does not mess around when it comes to finding ways to get money out of people. We have a database, we have a theme, now let's dive in. When it comes to operators in SQL, there are 2 ways we can look at them, in written order or in the order of execution. Let's talk about this, and I think the best way to do so is with a long-winded tangent which barely relates to what we're doing. Okay, I just wanted to go off on a tangent. Let's talk about generations of languages. The first generation of languages was machine code. That is, the ones and zeros which power everything. A first generation language provides the CPU explicit instructions, which is great, except that it ties you to a particular model of CPU, is nearly impossible for a human to read, and is extremely easy for a human to mess up. It's safe to say that nobody uses first generation languages directly. The second generation of languages includes assembly language. This abstracts away the binary ones and zeros and instead allows programmers to provide operations on bits of data in registers. There are some people who write programs in assembly language, but that's rare. Most commonly, people use third generation languages. Third generation languages have 2 key attributes. They are procedural and they are structured. This makes it a lot easier for a human to write and read code, and we can use compilers to translate that code into something machines can read. So win-win. Almost every programming language you're familiar with is a third generation language. Fourth generation languages move us one more level toward indirection. What I mean by this is that when we write code in a third generation language, we are telling the machine what to do. When we write using a fourth generation language like SQL, we don't tell the database engine what to do. We tell it what we want and let it figure out the best way to get there. This makes it easier for a human to write code, as SQL developers spend less time thinking in terms of algorithms and data structures, and spending more time thinking in terms of filters and result set shapes. But this has an important implication for us. A SQL query, even though it has individual operators, is an entity in itself as far as we are concerned. Behind the scenes, the database engine tears apart our statement and converts it into a set of computer operations which provide us some kind of result. The way the database engine parses the query is actually a little different from how we write it. For example, a simple query of select column from table has our select operator appear first, as that's what the SQL standard requires. Then we add the from clause. In reality, the database engine processes the from clause first and the select clause later. Going back to our list of operators we're looking at today, here they are in the order that we'd type them out. But the database engine actually handles them in this order. As a human, you can read them in either order, though understanding how the database engine works can assist you in query tuning, as well as figuring out why certain queries may have results you didn't expect. By the way, there are additional generations of programming languages which exist and serve as even more levels of indirection from machine code. Briefly, fifth-generation languages build knowledge systems in which a human expert explains to a computer the rules of the world, and the computer draws inferences from this. 5GLs had their heyday in the early 80s, but kinda died off with the AI winter, and so far they haven't come back into vogue during our current AI renaissance period. Sixth-generation languages also exist. These are no-code or visual development systems. Tangent over. Let's get back to SQL. I'm going to start with a select operator. The reason for this is that, at least in T-SQL, I can write a valid query using just this operator. By the way, I keep throwing around the name T-SQL, so let's quickly define it here. SQL, the structured query language, is, as I mentioned before, a fourth-generation language. It is a domain-specific language for working with data, and although it's not a perfect language, it does an outstanding job at the task. The official standard for SQL as a language is the ANSI standard. Then, vendors implement their variants on the standard, with some hewing closer to the standard than others. Microsoft's version of the language is Transact SQL, or T-SQL. It implements a very large portion of the ANSI standard, but not all of it. Also, T-SQL has some things which ANSI SQL lacks, and sometimes T-SQL has something which also exists in ANSI SQL but under a different name. Now, let's start simple. Select 1. If I run this in Azure Data Studio, I get back a result set with just the number 1 and no column name. This isn't the most valuable result set ever, though it does prove our database engine is working, so it's got that going for it. Also, note the semicolon at the end. SQL Server has, since 2008, required semicolons at the end of statements. Running a SQL statement without a semicolon at the end is obsolete. That's a threat they'll never make good on. So much code, including code that Microsoft has written and is a core part of SQL Server, would break if they ever removed support for queries which did not end in semicolons. Still, it's a good idea to get into the habit of using them. Now, let's spice this up a little. For my next trick, I'm going to start things backwards, with a from clause. The method to my madness is as follows. By adding the from clause and specifying tickets.parking violations, it'll be easier for me to perform the select operation. Before I do that, note that I've aliased the table name. This is another good practice to follow, especially once we introduce joins and other levels of query complexity. I'll add a select clause now and specify pv dot, and you can see that IntelliSense has filled in the possible column names. This works in Azure Data Studio and SQL Server Management Studio, as well as third-party tools like Redgate's SQL Prompt. Don't always count on IntelliSense to get things right, however. Sometimes you'll just need to do some typing of your own. I'm going to select ticket number, violation ID, officer ID, and fine amount. Before I run this query, however, let's do one more thing. Limit the number of rows coming back. If I run this query as is, SQL Server will return back approximately 54 million rows. That's way too many for us as humans to process in any meaningful fashion, and it would take a while for SQL Server to read the data from disk into memory, process the data in memory to include the columns we need, package those up into network packets, send the data across the network to our client, unpackage the data on our client, and process the results. The way around this is the top operator. Top is something we place immediately after select, and you put in parentheses the number of records you want back. There are times when SQL Server will process the query without parentheses, but that's also bad practice and something we should avoid. Anyhow, now that I've run this query, we can see 50 results come back for different violations associated with different officers with different fine amounts. I'm interested in violation ID 1, which represents parking or standing prohibited any time. And I'd like to get the first 50 cases of it. To do this, let's add a where clause and state we want cases in which violation ID is exactly 1. If we run this query, we can see that the fine amount for the first 50 tickets of violation ID 1 is consistently $30, and officer 32024 shows up a couple of times. So let's add another condition. Violation ID 1 and officer ID 32024. There's more that we can do here in the select clause, but my producer only allows me to go down 2 rabbit holes per video, so maybe I'll save that for a future video. Naturally, now that we have seen this officer write this ticket at least 50 times, the question is, how often do we see violation ID 1? Let's rephrase this query a bit and find out. I want to add a count function to my select clause. To do that, let's remove the top 50 bit and replace our select contents with count star, which I'll alias as number of violations. Running this query, we can see that Officer 32024 has 611 instances of violation ID 1. But how about other officers? I don't want to fill in every officer number here, so there's got to be a better way. That better way is the group by clause, which allows me to add non-aggregated columns in T-SQL statements, which include aggregate functions. First, let's add officer ID to the select clause. Now, we can add a group by clause after the where clause and remove the filter on officer ID from the where clause. In group by, I'll include every non-aggregated column in my select clause. Running this gives us back 33,771 rows, meaning that over 33,000 individuals have written a ticket for this violation type. We can see that the number of violation ranges from low teens into the thousands. So let's look at the people who gave themselves carpal tunnel writing these tickets. Let's say we only care about officers who have written more than 10,000 such tickets. We can introduce the having clause to solve this problem. Having is a filter for post-aggregated groupings, similar to how where is a filter for pre-aggregated data. Putting this clause in, we can rerun the query and get back the 12 officers who have written at least 10,000 tickets for this. It's a lot of tickets. Now there's a small enough number that we could eyeball the set and figure out which officer wins the ticket writing contest. But let's do it a smarter way, adding an order by clause. In the SQL language, there is no concept of order without an explicit order by clause. In other words, you might get data which is sorted in a particular way one run, but there's no guarantee that it will be the same ordering the next time around. The only way to make this guarantee is to add an order by clause, like sorting by number of violations descending, so that the largest number is at the top. Note that I can use the alias number of violations that I defined in the select clause. Also, if I wanted to sort things smallest to largest, I'd use ASC for ascending instead of DESC. Rerunning this query, Officer 26920 wins the prize. Incidentally, if you are in Azure Data Studio, you can also sort results without having to rerun the query. This is nice if the query takes a long time and you just need a quick sorting. The last thing we'll look at is the distinct clause. Let's say I am interested in the distinct set of fine amounts in this table, but don't care about counts or anything like that. Let's remove everything except the select and from clauses, mark fine amount as the one column we need, and slap a distinct on after the select. What this will do is pull out all of the data, find the set of fine amounts, and return one record per different fine amount. As we can see, there's no explicit ordering. So let's run that one more time after adding an order by fine amount. Because I didn't specify ascending or descending, SQL Server uses ascending as the default. And that'll do it for this video. We've gained an understanding of how select statements work in SQL, both the ANSI SQL standard and the T-SQL dialect that SQL Server uses. As I alluded to in the intro, there's still a lot more in the world of querying, so in the next video, we'll dive a bit deeper. We'll have links and show notes in the description below. And until we see each other in the next video, take care.